Kami ay narito, tapat sa aming serbisyo. Walang problemang di malalampasan. Magliliwanag ang ating kinabukasan. DANHS Radio, silid-aralan sa radyo. Hatid namin makabagong paraan ng pagtuturo. Kahit saan at kahit kailan, hindi ka iiwanan. Hatid namin bagong kaalaman. Edukasyo'y susulong, basta't magtulong-tulong. Sulong edukalidad, DANHS Radio. Learning is amazing.
Ito ang 106.3 DANHS Radio. DANHS Radio.
Prepare yourself.
Ang silid-aralan sa radyo, hatid namin ay makabagong paraan ng pagtuturo at kalaman. Mapaumaga, tanghali o hapon man yan, ang istasyong magbibigay impormasyon kahit saan man.
For something big.
Alright, here we go.
106.3 DANHS Radio. Doña Aurora National High School, Santa Rita, Aurora, Isabela.
This
106.3 DWDR-FM. Physics, Chemistry, Earth Science, Biology, Biochemistry, Environmental Science. These are some branches of science. Science is about a whole lot more than that. And to sum it up, we believe that science is the way of helping the brain grow in finding new knowledge and help us defeat our curiosity and how the world develops and works today. Science. This is your class, and this is science.
Good morning! Good morning, good morning po. It's another wonderful and blessed day for us. Ayan, thank you for tuning in to our station 106.3 DANHS Radio, where learning is amazing. Shout out sa ating mga 10 Archimedes, 10 Galileo, and 10 Newton. Galaw-galaw, bangon-bangon, at simula ng araw ng may saya. Ayan. Welcome to another episode of Scienterrific Time. Sit back, because we are about to start our RBI airing about fluids, their properties, and applications. Ayan, mag-ready na ng inyong mga pen, notebooks, and ayan, mga ballpen and notebook. Siyempre, okay, so makinig na tayo and stand by or stay tuned for the live discussion after the RBI airing. Okay, take it away, Sir Joshel.
DANHS Radio, silid-aralan sa radyo. Hatid namin makabago
Wala nang makakapigil pa. Sulong Arangkada 106.3 DANHS Radio sa Aurora, Isabela.
Edukasyo'y susulong, basta't magtulong-tulong. Sulong edukalidad, DANHS Radio. Learning is amazing.
Physics, Chemistry, Earth Science, Biology, Biochemistry, Environmental Science. These are some branches of science. Science is about a whole lot more than that. And to sum it up, We believe that science is a way of helping the brain grow in finding new knowledge and help us defeat our curiosity of how the world develops and works today. Science. This is your class, and this is Science. And now, here is your host for the day. Good day, our beloved students and listeners of Grade 10 Special Science Curriculum. This is your School on the Air in Science. We are so happy that you are always listening on the School on the Air in Science. Thank you for continuously tuning in to 106.3 DWDR-FM Dance Radio. Together, let us listen, discover, and learn scientific knowledge and important facts. This is your host, Teacher Dennis Mendoza. With me is Teacher Riza Marzan, our technical specialist. How are you today? I hope that you are in good condition. If you have any question and inquiry about our lesson, you may text or call your subject teacher using the number which can be found in your learning package. You may also send your questions through their messengers and their emails found in your learning packages as well. I know that you are now ready and excited to learn. So, here's your teacher on the air, Teacher Benjelu Paraiso.
Good day, our Grade 10 Special Science Class learners. This is Teacher Benjelu, your teacher on the air. I am so glad to know that amidst this pandemic, you're still giving your best in performing your learning task. Settle yourselves in the most comfortable place while listening intently to our discussion on the air. Please open your learning activity sheets and check if the pages are complete. To be guided in using this module, please observe the following. Number 1. Read and follow the directions and instructions in the activities and exercises carefully. Number 2. Take your time in reading the lessons. Number 3. Answer honestly all the given test activities or exercises. Today's lesson is about fluids. Last week, we discussed about the electrical quantities and circuit. What are the three basic electrical quantities again?
The three electrical quantities are current, voltage, and resistance, ma'am.
That's right. How do these three differ from each other?
Current is the measure of how much charge passed through a given point in the conductor per given amount of time and is measured in amperes, ma'am. While voltage is the electric pressure that causes current to flow and is measured in volts. While resistance is the opposition of a material offers to current and is measured in ohms, ma'am.
Very well said. What are the types of electrical circuits?
The series, parallel, and series parallel circuits or network, ma'am.
Correct. Will you describe each circuit briefly?
A series circuit has two or more loads, but current flows through a single conducting path. The current that flows through each resistor is the same as the total current throughout the circuit, ma'am.
Definitely. How about the other two types of circuits?
A parallel circuit has more than one path for current to flow, ma'am. The total current that flows through the circuit is equal to the sum of the currents in separate resistances, ma'am.
The series parallel circuit is a combination of both series and parallel circuits, ma'am. And they are of different electromotive force. This type of electrical wirings are used in big buildings and structures.
Precisely. Wow! Based from the way you answered, I think you have understood the past lessons clearly. Do you have any question on the last topic?
None, ma'am.
Very good. Today, we will be discussing about fluids and the principles associated with it. At the end of the lesson, everyone is expected to describe fluids and calculate fluid pressure and express its dependence on depth of fluid. We'll have the discussion after this reminder.
Ikaw ba ay batang magtatapos ng elementarya ngayong taong panuruan 2020-2021?
O di kaya'y batang nagnanais lumipat o bumalik sa pag-aaral sa ating paaralan?
Simula sa ika-26 ng Marso
hanggang ika-31 ng Mayo
ay magsasagawa ang Doña Aurora National High School
ng pagpapatala
o early registration para sa taong panuruan 2021-2022.
Bisitahin ang Facebook page ng Doña Aurora National High School
at i-click ang link upang makapagtala sa takdang araw.
Para sa mga hindi makapag-access online, huwag mag-alala, i-aanunsyo sa ating istasyong 106.3 FM
DANHS Radio ang iba pang impormasyon
tingkil sa ating early registration.
Mag-register na! Maging parte ng Amazing Dance Family!
Isang impormasyon mula sa pamunuan ng Doña Aurora National High School at ng himpilang ito.
It's Science Time! You are listening to Teacher Benjulu.
And I'm back! Are you excited to learn about our topic today?
Yes, ma'am.
That's great! Now, why do ships float where in fact they are made of iron and steel?
Much of the interior of a ship is air compared with a bar of steel which is solid. The average density, taking into account the combination of the steel and other materials and the air, can become less than the average density of water, ma'am.
Wow, very good idea. The concepts behind such question is all associated with fluids, their properties, and the principles behind their behaviors. This will be discussed today. To start, let us first define fluid. When you hear the word fluid, what comes into your mind?
Fluids are those that can flow, ma'am.
If a matter can change shape easily, then it can be considered as fluid, ma'am.
Thank you for sharing your ideas, my dear learners. Actually, your ideas are correct. Fluids are substances whose shape can easily change and are able to flow. They offer less resistance to a change in shape when subjected to pressure. From this definition, can you give examples of fluid?
Aside from water, I think air can be considered fluid, ma'am, because it flows and follows the shape of its container just like the water. Both gases and liquids are fluids, ma'am.
Precisely! Fluids include liquids, gases, and even plasmas. Water is a fluid, air is a fluid, the sun is a fluid, since it is a huge ball of gases, and even molasses are a fluid. There are different properties of fluids that will help us understand fluids clearly. However, we will be focusing on the major properties only. Other properties will be tackled in your higher years. Will you give one of these properties of fluids?
Density, ma'am.
Do you have any idea what density is?
Density indicates how heavy a substance is with respect to its volume, ma'am.
Good! Density is defined as the ratio of an object's mass to the volume it occupies. There are objects that are big in volume but light in mass. Also, there are objects that have the same volume but different masses. For example, a beach ball may have the same volume as a bowling ball, but it has a much smaller mass. These objects have different densities. Moreover, unlike mass and volume, density is independent of the amount of matter present in a substance. What does this mean?
That means that a substance has the same density regardless of its mass, ma'am.
Correct. For example, if you break a piece of chalk, Each piece may have half the mass and half the volume, but its density remains the same. Did you get that?
Yes, ma'am.
Very good. Density is defined by the equation ρ is equal to m over v, where ρ is the density, while m is the mass, and v is the volume of the object. Density is measured in kilogram per cubic meter, and it is symbolized or represented by the Greek letter ρ. What does the equation ρ is equal to m over v imply?
Density is the ratio of mass and volume of a fluid, ma'am.
Very good. Let us try to determine the density of a kilogram of gold, which occupies a volume of 5.18 times 10 raised to negative 5 cubic meter. What are the given quantities in that statement?
The given quantities are the mass of the gold, which is 1 kilogram, and its volume, which is 5.18 times 10 raised to negative 5 cubic meter, ma'am.
Correct. Based on those given, what is the formula that can be used?
To find for the density, use the equation density is equal to mass divided by volume, or ρ is equal to m over v, ma'am.
Precisely. Substituting the given values, 1 kilogram divided by 5.18 times 10 raised to negative 5 cubic meter, what will be the value of the density?
It will result to 19,300.2 kilogram per cubic meter, ma'am.
Very good. That means a 1 meter by 1 meter by 1 meter volume of gold has a mass of 19,300.2 kilogram. That is heavy, right? That is how density is computed. The other quantities, volume and mass, can also be computed using the same formula. I am sure you all know how to derive formulas.
Yes, I do, ma'am. If mass is to be determined, the formula to be used will be mass is equal to density times volume, or m is equal to ρ times v, ma'am. On the other hand, to solve for the volume, the formula to be used will be volume is equal to the mass divided by the density, or v is equal to m over ρ, ma'am.
Very good. It seems that you are really good in deriving formulas. Now, why do some objects float and others sink?
Ma'am, the objects that float are those that are less dense than the fluid. Wood, oil, sponge, and kerosene all float in water, while rock, marble, steel, and iron sink in water, ma'am.
Very good. The difference in densities causes some objects to float or sink. Any object denser than the fluid in which it is immersed will sink. Okay, let's consider a simple situation. Will an aluminum sink or float in water? The density of aluminum is 2.7 times 10 raised to 3 kilogram per cubic meter, while the density of water is 1 times 10 raised to 3. What do you think?
The aluminum will sink, ma'am, because its density is higher than the density of water.
Very good. How about in mercury, which has a density of 13.6 times 10 raised to 3 kilogram per cubic meter? Will the aluminum sink or float?
The aluminum will float, ma'am, since it is less dense than the mercury.
Definitely. Mercury is a dense, silvery D-block element. It is the only metal that is liquid at standard conditions for temperature and pressure. The concept on density applies to different materials with varying densities. That is one of the properties of fluids. Is everything clear?
Yes, ma'am.
Okay, Let us proceed to the next property of fluids, the pressure. Pressure is defined as the force exerted per unit area. There are two different types of pressure, the hydrostatic and atmospheric pressure. The pressure exerted on an object by a column of fluid is called hydrostatic pressure, while the pressure exerted by air is referred to as air or atmospheric pressure. Okay, I have a question. Have you tried swimming underwater? What can you feel as you go deeper?
It is harder to swim as you go deeper, ma'am. Maybe it is because the pressure underwater increases as you go deeper, ma'am.
That's right. The deeper you dive, the greater the pressure. Always remember that pressure increases with depth. The deeper you descend, the more water you have above you, and the more pressure it exerts on your body. The pressure one experiences at a certain depth is the sum of all the pressures above him or her, both from the water and the air. That is why it feels harder to swim in the deeper portion of a body of water. Did you get that?
Yes, ma'am.
Suppose we have 3 containers of different shapes, a glass, a flask, and a test tube. The liquid surface in each of the container is at the same levels. What can you say about the pressure at the bottom of each container?
The pressure at the bottom of each container will be the same, ma'am, because the pressure exerted by a fluid is transmitted equally in all directions.
Very good. What does this imply?
The shape of the container does not affect pressure, ma'am.
Correct. Pressure is the same at any particular depth in liquid contained in vessels of different sizes or shapes. Consider 3 drinking glasses. All have the same area base, and all are filled to the same surface level with water. Glass A is cylindrical. Glass B is wider at the top than at the bottom, and so holds more water than A. And glass C is narrower at the top than at the bottom, and so holds less water than A. Which glass do you think has the greatest liquid pressure at the bottom?
I think the pressure at the bottom of the containers are the same, ma'am, since the liquid surface in each container is at the same level and the pressure is distributed in all parts of the container.
That's right. Then, does the amount of liquid affect pressure?
I think the amount of liquid does not affect pressure, ma'am.
Yes, you are correct. Pressure does not depend on the amount of liquid.
I got it, ma'am.
Very good. Suppose a block of brass and a block of wood have exactly the same mass. If both blocks are dropped in a tank of water, which of the two will float and which will sink?
The wood will float and the brass will sink.
That's right. But why?
This occurs because the brass has a greater density than water, whereas the wood has a lower density than water, ma'am.
Very well said. Then, what can you deduce from that example? How does density affect pressure?
The denser the object, the greater the pressure it exerts, ma'am.
Definitely. Denser fluids, such as water, exert more pressure than less dense fluid like air. Why is this so?
It is because the particles of denser fluids are closer together, ma'am.
Very good idea. Particles of denser fluids, for example water, are closer together than the less dense fluid like air. So, there are more collisions of particles in a given area. Are the factors affecting pressure clear now?
Yes, ma'am.
Very good. How do we then calculate pressure?
Pressure, due to the weight of a liquid of constant density, is given by P is equal to rho times G times H, ma'am. Wherein P is the pressure, H is the depth of the liquid, ρ is the liquid, and G is the acceleration due to gravity, ma'am.
That's correct. We will discuss the equations and sample problems on pressure in the live discussion later, so stay tuned. We will be right back after an infomercial.
Mga kaibigan, sa panahon ngayon, kailangang magpalakas ng katawan.
Kumain ng masustansyang pagkain at sabayan ng pag-eehersisyo.
Huwag ding kalimutan ang pag-inom ng vitamins. Resistensya ay palakasin. Kalusugay huwag pabayaan upang sakit ay maiwasan.
Isang paalala mula sa himpilang ito.
It's Science Time! You are listening to Teacher Benjulu.
Welcome back! Let's continue. If you get a piece of cork, immerse it in water, and release it, what will happen?
The cork will float, ma'am.
Correct! Try to push down the cork in the water. What do you feel?
It feels that there is an upward force coming from the water, ma'am.
Yes, that's true. The upward force resulting an object wholly or partially immersed in fluid is called the buoyant force. It is one of the important concepts associated to fluids. A very important principle explaining the relationship between buoyancy and displaced liquid was discovered by the Greek mathematician named Archimedes. It is known as the Archimedes Principle. Will you state the principle?
Archimedes Principle states that a body partly or wholly submerged in a fluid, buoyed up by a force equal in magnitude to the weight of the displaced fluid, and is directed upward along a line through the center of gravity of the displaced fluid, ma'am.
Very good! Actually, one of the oldest and well-known tale revolves around Archimedes' legendary Eureka moment while taking a bath in a tub, when he made a remarkable discovery, what is now known as the Archimedes Principle. Supposedly, Archimedes was so thrilled and excited with this discovery that he immediately hopped out of the bath and ran onto the streets to tell the king, shouting loudly, "Eureka! Eureka! I have found it! I have found it!" in delight. The discovery of Archimedes cleared the suspicion of the king about his gold crown. Eureka! Eureka! Simply put, the buoyant force on an object submerged in fluids is equal to the weight of the volume of fluid it displaces. What do you think will happen if the buoyant force is equal to the weight of the body submerged in a fluid?
The body will remain at any level in the fluid, ma'am.
Definitely. How about if the buoyant force is greater than the weight of the body?
The body will float, ma'am.
Correct. If the buoyant force is greater than the weight of the body, it will float, whereas if the buoyant force is less than the weight of the body, it will sink. Why is it that a block of steel sinks but a steel ship floats? A steel ship is hollow and occupies a wider space than the block of steel, ma'am. That's right. The steel ship is shaped in such a way that it displaces more water than the volume it would normally occupy. The water displaced by the ship's hull weighs as much as the ship does. Remember, the greater the volume of water displaced, the greater the buoyant force. Is that clear?
Yes, ma'am.
Great! We will discuss more of buoyancy in our live discussion. Apply the concepts that we have discussed in answering the activities 1 and 2 in your learning activity sheets. But before that, Please make sure to attend our live discussion for deeper understanding of our topic. Please answer them honestly. Do you have any question, my dear learners?
None, ma'am.
That's great! What are fluids again?
Fluids are substances that easily change shape and are able to flow like air and water, ma'am.
Very good! What are the important properties of fluids?
Pressure, buoyancy, and density, ma'am.
Those are some of the important concepts associated with fluids. Is learning about fluids important, my dear learners?
Yes, ma'am. Knowledge on fluids and their properties help us understand many phenomena happening in our lives, such as why objects float or sink, and many more, ma'am.
I now understand how fluids behave, and I can apply this in my daily life. I now understand why swimming into deeper part of a body of water is very dangerous. As one descends, water pressure increases and the volume of air in the body decreases. This can cause problems such as sinus pain or a ruptured eardrum. As you ascend, water pressure decreases and the air in your lungs expands. This can make the air sacs in your lungs rupture and make it hard for you to breathe. If air bubbles get into an artery, they can cause a blockage that affects your organs. The blockage is called an arterial gas embolism. Depending on where the bubbles are, you could have a heart attack or a stroke, ma'am.
Amazing! With that, please continue your enthusiasm to learn more science concepts. If you have some questions and clarifications, keep listening so you can learn more. If you have a hard time in understanding the directions, do not hesitate to ask help from your parents, or you may call your subject teacher for assistance. We're about to end our episode for today in Advanced Physics. I hope you enjoyed listening to our discussion. Again, this is Teacher Benjelu, your teacher on the air.
You have just listened to Teacher Benjelu Paraiso. I am encouraging all of you to give us feedback regarding the flow of our lesson for today. For your question and inquiry about our lesson, you may text or call your subject teacher using the numbers located at your learning packages. You may also send them your questions through their messengers and their email found in your learning packages as well. Our class in Advanced Physics has just ended. You can now start working on the other parts of the learning activity sheet to enhance your understanding of how evolution happens. Do well in answering your activities. I would like to acknowledge the teachers behind this School on the Air lesson. Teacher Mirna V. Enriquez, the scriptwriter, Teacher Benjelu Paraiso, and Teacher Vicente S. Rodriguez, our quality assurance team. Teacher Benjelu R. Paraiso, your radio teacher. And Teacher Risa N. Marsan, our technical specialist. And yours truly, Teacher Dennis, your radio host. Keep safe and God bless you all throughout this day. Stay tuned for the next episode. Goodbye. Physics, chemistry, earth science, biology, biochemistry, environmental science. These are some branches of science. Science is about a whole lot more than that. And to sum it up, we believe that science is a way of helping the brain grow in finding new knowledge and help us defeat our curiosity of how the world develops and works today. Science. This is your class, and this is Science.
Dance Radio, siniparalan sa radyo, atid namin makabago, paraan ang pagtuturo.
Wala nang makakapigil pa. Sulong Arangkada 106.3 DANHS Radio sa Aurora, Isabela.
Edukasyo'y susulong, basta na magtulong-tulong, sulong edukalidad. DANHS Radio, learning is amazing.
Ayan, and we're back. Thank you for staying tuned. Okay, shout out ulit sa mga listeners natin sa radyo, sa FB Live, and syempre sa YouTube. Ayan, meron tayong YouTube channel natin, Ma'am Mirna. 106.3 FM Dance Radio. I-plug ko lang. Ayan, don't forget to subscribe. Ayan, live na live tayo dyan sa YouTube. Okay, so with us today are the scientific teachers. Ayan, to start with Ma'am Mirna Enriquez.
Okay, hello. Thank you, Ma'am Jen. Good morning po sa lahat, sa ating mga learners, most especially sa ating grade 10 SSC learners. Special mention dyan ang grade 10, Archimedes, Galileo, and Newton. I hope nakatune in na kayo mga anak dahil ito ay para sa inyo. And doon naman sa mga regular science learners, no, thank you for tuning in. May mga nakita na ako kanina and I'm so happy. Very active po ang grade 10 Sulaiman and grade 10 Silang. Okay, mga anak ko rin yung mga yan. Okay, so thank you for tuning in. Yes, Ma'am Jen.
Okay, and also Ma'am Donabel Velasco.
Hello, good morning everyone. Lalong-lalo na sa mga grade 10 learners. Ayan. So, kahit wala sa special science class at kung nakatutok kayo, these are additional information, additional lessons for you to learn. Okay po?
Ayan. And kasama natin via Zoom, Ma'am Benjelu Paraiso.
Hello, good morning. Morning po. Shout out sa aking Chunakis, 10 Archimedes, at ang aking mga classes sa 10 Galileo. Hello everyone.
Okay, and kasama din natin via Zoom din si Ma'am Fernandina Benito. Hello, Ma'am.
Hello, good morning po sa ating lahat. Hello sa mga grade 10 science class, kahit hindi nyo ako teacher, nandito ako para sa inyo. Then, meron din akong alam nyo ba na meron din grade 9 na nakikinig?
Oh, wow.
Oo, may grade 9, may nakita ako na grade 9 ko. O, di ba? Advanced na sa kanila yun siguro, o di ba? Para merong advanced learning.
Oh, yes, ma'am. And
Okay po.
napakagandang
Yes.
balita niyan, ma'am. So,
Yes, ma'am, may nakita ako sa mga estudyante ko a while ago.
so lahat po invited to join para po sa additional learnings.
Okay, and syempre, pakilala na rin ako, ma'am, yours truly, your host, Teacher Jennifer Lacambra. Ayan, so makakasama nyo kami ngayon to explain further the topic on fluids, their properties, and application. So ang subject natin ngayon is advanced physics. Okay, so Ma'am Mirna, ano ba ang mga matututunan natin ngayong araw na ito?
Okay, yes. After this live discussion, the learners are expected to be able to describe the properties of fluids, okay, explain the Archimedes and Pascal's principles, and of course, their application. Okay, we will also discuss sample problem solving involving fluids. Okay, so yan, napakahalaga ng ating topic ngayon kasi as we go on mamaya, makikita ninyo, okay, napaka-applicable pala nito sa ating daily lives.
Ayan, so hindi na tayo magtatagal. Let us start. Okay, to start with what is fluid and examples? Let's have Ma'am Dina Benito.
Okay. So, gaya po ng sabi ni Ma'am Mirna kanina, we will be discussing about fluids. Kumbaga, ito yung wala doon sa RBI natin. So, we are going to have, or we're going to deepen our understanding about fluids. So, when we say fluids, ano ba itong mga fluids na sinasabi natin? Okay, so it is a substance that is capable of flowing. Capable of flowing. Ano yon? Umaagos, di ba? Yun yung ibig sabihin nun. Lahat ng umaagos ba? Fluid. Okay. Another is, it has no definite shape of its own. Bakit natin sinabi na has no definite shape of its own? Kasi ang mga fluid, they vary the shape or they assume the shape of its container. So halimbawa, yung shape ng container natin is round or pa-circle siya. So therefore, the shape of that fluid, that particular fluid, is also circle. O another is yung shape na puso. Paano ba yung korteng puso? So pag yung fluid nilagay natin sa korteng puso na container, then yun din yung magiging shape nung fluid na yon. Okay, so its shape can easily change. It offers a little resistance to a change in shape when subjected to pressure. Parang narinig ko kanina ito dun sa may RBI natin, dun sa airing ng lesson natin kanina. Okay, yung sa pressure, it is one of the many characteristics ba yun, Ma'am Mirna? Yung pressure na about
yes,
fluid?
Ma'am Dines, opo.
Okay,
And we will discuss
so,
that
sabihin,
further mamaya.
Oo, nakinig din ako, So, dapat tayong lahat makikinig para mas marami tayong matutunan. Okay, then, we have both liquids and gases are fluids. So, ibig sabihin, hindi lang mga liquid ang fluid. Meron din tayong mga gases na fluids. Meron pa nga yatang plasma eh.
Yes,
diba?
Ma'am Dines.
Meron ding plasma.
Yes.
Di ba, Ma'am Mirna, meron ding plasma?
Yes, Ma'am Dines.
Na fluid.
And actually, pati yung ating sun. Okay, that is an example of
yes, oo. Okay, so those are then, yun yung mga characteristics of fluid natin. Okay, so, it is a substance that continually deforms under an applied shear, stress, or external force. Yan yung fluid. They are also, of course, a phase of matter and includes, ito na yung sinasabi ko sa inyo kanina, na hindi lang mga liquids, also gases, and of course, plasmas are also examples of fluids. They are substances with zero shear modulus. Or, in simpler terms, ito yung mga substances which cannot resist any shear force applied to them. So, yan po yung fluid natin. Okay, so let's move on to the different, or what are the different examples of fluid? Okay. So, nandyan sa screen natin, nakikita nyo ba mga mag-aaral? We have ketchup. Sino yung mahilig gumamit ng ketchup? Okay, we have also quicksand. We have also the different types of emulsions. Ano ba itong mga ito na nag-aralan natin before? Okay, ano pa? Flour. Alam mo yung are you familiar with yung slime?
Slime, yes ma'am. Slime, flour. Flour
yung slime?
Slime, opo.
Di ba ang gandang, parang yung slime, parang stress reliever din siya, yung slime.
Okay, actually,
parang
Ma'am
ang ganda
Dai,
kasing hawakan yun eh.
Okay,
yes?
Actually, Ma'am Dai, yung mga pinapresent nating mga examples dyan, ay akalain mong hindi mga fluids, no? Siguro naisip nila, fluid ba yan? Okay, actually...
Yes, kagaya ng gel, ma'am.
Opo.
Di ba yung gel?
Yes, ma'am.
Kasi kung pagbabasahan natin yung binigay natin na definition ng fluid, parang hindi sila kasali, di ba?
Okay, yes, ma'am. Actually, ang totoo dyan, we also have this 5 types of fluids. Okay, so ito yung mga example na binigay mo kanina ay under dito sa 5 types ng fluid. Okay, for example, yung ating ketchup kanina, that is an example of pseudoplastic fluid. Ayan, saka yung quicksand natin. Okay,
Yes,
a
ma'am.
fluid whose apparent viscosity or consistency decreases instantaneously with an increase in shear rate. Okay.
Shear,
Opo,
yes,
and then yung
shear, ano
Opo,
yun? Stress.
stress, yes.
Okay.
Tapos yung
Toothpaste, akalain mo ba yun?
Opo.
Na fluid siya, ma'am.
Okay,
Di ba
example po
hindi?
yan naman ng tinatawag natin na non-Newtonian fluids. Okay, ano naman
Yes.
to? These are the fluids that do not obey Newton's law of viscosity. Kasi actually,
Yes.
viscosity is also one of the properties of fluids, pero hindi natin masyadong madidiscuss yan kasi they will take up that concept sa susunod nilang mga lessons kasi tutuloy natin yan sa
okay.
ating fourth quarter.
At least, ma'am, meron na silang background.
Yes, ma'am.
And the other properties of fluids.
Okay.
Yes.
So those are the examples.
Pero alam niyo ba na ang the most familiar example of fluid is water? Siyempre, of course, di ba? Okay, so siya yung pinaka-familiar na example ng fluid, yung water. Tama ba ako, Ma'am Mirna?
Yes, ma'am. At yan ang gagamitin nating mga best example mamaya as we go on with our discussion dun sa ibang properties niya. Okay, so thank you,
Sa ibang
Ma'am
mga
Dai.
properties. Yes, ma'am. You're welcome.
Okay, thank you, Ma'am Dines. So, next is...
Okay, we will be discussing about the properties of fluids. So, to give us or to enlighten us about the first property, we will have Ma'am Benjelu Paraiso to explain density.
Thank you, Ma'am Mirna. Okay, so napakaganda no ng discussion kanina kasi nalaman natin na ang fluid pala may iba't ibang types. Hindi lang pala siya parang pag sinabi nating fluid, water agad-agad. Tama, water agad-agad ang maiisip natin. Pero ang air pala is another example of fluid. Tama? Kasi nga, fluid is anything or a matter that can flow, that can easily change its shape. At pasok na pasok sa definition talaga itong air. At nasabi rin nila, Ma'am Yorna kanina, maraming klase pala ng fluids, no? Ang alam lang natin, basta pag sinabing fluids, yung napakadaling dumaloy. Pero yun pala, napakaraming klase pa. Yun palang mga gel, mga cream natin, mga mayonnaise, lahat pala yan ay...
Diba?
Oo, fluid pala sila, no? Okay, additional na, actually, higher physics na kasi yun. No, nagdagdag lang talagang features natin ng mga information. Okay, so first property ng fluid is density. Kahit naman nasa lower year kayo, alam natin kung ano sabihin ng density. Pero syempre, in this discussion, ang bibigyan natin ng attention and focus is on fluid density. Okay? So, ang general definition ng density is the ratio of the object's mass per unit volume. Okay? Or, pwede yun sa solid, pwede rin siya sa liquid. Okay? Mass per unit volume. Okay, so kung titingnan natin yung definition na yon, madali nating makikita kung anong mga quantities ang involved doon. Number 1 is the mass of the object. Number 2 is the volume of the object. Okay, so before we proceed to a deeper discussion, ang density, it is represented by a Greek letter rho. Para siyang letter P na cursive, pero hindi naman siya totally cursive na letter P. So, it is the symbol or representation of density. Okay? So, if we are going to make an equation for density, gamit yung ating definition, we can have density is equal to mass over volume. Or, rho is equal to m over v. Okay? So, kung titingnan natin itong quantities na meron tayo, pwede nating makuha rin kung ano yung mga units na nagre-represent ng ating density. Bakit importante na kailangan or bakit importante alam natin ng unit? Tulad ng lagi namin sinasabi, pag alam na natin ng unit, automatically pag nakita natin yung unit ng certain quantity, alam na natin kung anong quantity yung associated doon. Kahit hindi binabanggit doon sa problem, hindi binabanggit doon sa ating Example, basta nakita natin ang unit. So, ang unit ng mass is usually in kilograms or in grams. Okay? Ang unit naman ng volume, it can be in cubic meter or cubic centimeter or other unit. Okay? Basta volume, naka-cube siya. Okay? Kasi length times width times height. Height nga tayo. So, pag ng unit na kilogram per cubic meter, it is a unit for density. If we see gram per cubic centimeter, it is also a unit for density. Ma'am, pwede po bang gram per cubic meter? Pwede. Ma'am, pwede po bang kilogram per cubic centimeter? Pwede rin. Pero usually, ang nagko-combine is kilogram per cubic meter or gram per cubic centimeter. Okay? So, density is the ratio of the object's mass unit volume. Now, in the screen, nakikita natin dito yung dalawang boxes na may iba't ibang number of particles. By that, this illustration, makikita natin kung ano bang ibig sabihin ng tinatawag nating density para ma-visualize lang natin, ano? Sa solid or parang pwede nating maano yan sa different phases of matter kasi. Okay, bigyan muna natin ng DN kung ano yung nakikita natin sa screen. So, if we have illustration of two boxes with different numbers of balls inside or particles inside it. So, makikita natin, in the first box, mas kokonti ang ating number of particles. In the second box, mas compact siya. Okay? Kung titingnan natin yan, sasabihin na natin na ang bawat isang piraso ng particle dyan ay may katumbas na timbang, makikita natin na ang unang box natin, it would be heavier in it would be lighter in mass than the second object, but they have the same volume. So, kung titingnan natin the ratio of the mass of the object inside the box with respect to its volume, makikita natin ang density na yung una nating box, it has a lower density. Bakit lower density? Kokonti yung particles inside it. Ibig sabihin, kokonti din or mas mababa ang kanyang mass per unit volume. Okay? Compare the other one. Kung titingnan natin sa mga phases of matter natin, ang pinaka-compact ang particles, mas pinakamaraming particles na pwede nating makita sa isang certain amount of volume is the solid matter, solid phase of matter. Then, susunod ang liquid, susunod ang gas. So, ibig sabihin, kung i-arrange natin ang density, densest ang solid, then followed by mas mababa ang density ng liquid, pinaka mababa ang density ng gas. Okay? So, malinaw ba tayo dyan? I hope so. Okay, now, let's proceed to the next slide. So, tingnan natin, no? So, titingnan din natin, actually, itong sumunod na slide natin, nandun na rin doon sa una nating discussion. Okay? Density is mass per unit volume or how closely packed the stuff is within an object. So, in gas, less yung less compact ang particles. For solid, sobrang compact. For liquid, lesser ang particles na are hindi ganong dikit-dikit compared to solid. So, if something is more dense, that means more stuff is taking up that object space and is more closely packed. Okay? So, lagi nating tandaan, ang density, kinukuha mo lang yung ratio ng mass at ng volume na kinalalagyan ng object na may mass na yon. Okay? Next slide tayo. Meron tayong example dito. Pwede natin siyang an analogy. Okay? An elevator with 15 people in it would be more dense than the same elevator with only 3 people in it. Okay, so sa base sa bilang ng tao na laman ng elevator, yung 15 na taong karga ng ating elevator, sa example, makikita natin that the elevator is really denser kapag 15 ang laman niya compared to 3 people. Okay? So, the number of people inside it, yung mass nang nandoon, i-add mo lahat yung total mass nun, then you get the volume of the elevator, you can get the density. Parang ganon. Okay? Parang ganon yung ating sistema dyan. Okay? Density does depend on size as well as how compact the molecules are inside. Okay? If I have the same amount of an object, let's say 10 grams, that is extremely dense, and an object that has a much lower density, let's say for example gold versus styrofoam, I will need much more of lower density substance to get 10 grams worth than the denser substance. Parang kumbaga, ang ibig sabihin nito, kapag pagkokomperahin natin yung dalawang bagay na magkaibang density, kakailanganin mo para magpapantay ang kanilang density in terms of, or halimbawa, magko-compare tayo ng dalawang object, yung lesser dense at saka yung denser, para, ano ko ba yun i-explain? Parang ako yung, kailangan ko ng mas maraming, pieces or mas maraming amount nung lower ng density ng substance kaysa dun sa marami para mapantayan or kaysa dun sa mataas ang density para mapantayan ko yung mas taas ang density or same amount. Parang ako yung naligaw dun sa bahaging yon. Okay, excuse me for that. Pero let's go deeper into that later. Okay, now, paano tayo nagko-compute ng density ng isang object? Okay, since we have the equation rho is equal to m over v, we can use our magic triangle. Okay? So, sa susunod na screen, makikita natin yung ating magic triangle. Doon sa pinakataas niya, we have there the mass, which m, which represents the mass of the object. Then, on the left side, we have d, but actually it should be rho, the density of the object, and then V on the right side, the volume of the object. If you're asked to compute or determine the density of an object, ang pinaka-madaling gawin nyo lang naman dyan is takpan nyo si letter D. Okay, pag tinakpan nyo si letter D, anong natitira sa atin? We have M over V. Tama po ba? Nagkaroon siya ng bar line, yung horizontal line dyan, that represents the bar line. So, madali nating ma-derive yung equation kung hindi man or matandaan yung equation. Density is equal to M over V. How about pagka-mass naman po ang hinahanap natin? Takpan mo ulit si M. Ano ang may titira sa atin? We have D times V naman yan. Okay? Multiplication naman yung vertical na line natin dyan. So, we have mass is equal to density times its volume. Pag volume naman, takpan mo naman si volume. Then, ang matitira sa'yo sa magic triangle, we have mass over the density. Okay? So, napakadali, di ba? Basta, actually, kahit sa mga estudyanteng mabilis magpaikot ng equation sa ulo, sa brain natin, kahit wala si magic triangle, gumagalaw yung ating mga quantities. Pero para sa pinadaling paraan, para sa lahat, ang ating magic triangle ay napakagandang device para sa derivation of equation. So, pwede natin gamitin yan, no? Pag magsosolve tayo ng density. Okay. So, punta tayo sa fluid na. Fluid na talaga. Ano nga ba ang density ng tubig? Bakit sabi nila kapag ang tubig, pure water, 1 liter siya, katumbas daw nito ay 1 kilogram din? Bakit kaya nila nasasabi na ang isang litrong tubig ay may timbang din na 1 kilogram? Kasi nga po, ang density ng water ay 1 gram per milliliter. Bawat isang milliliter, ang bigat niya ay 1 gram. So, ilan bang milliliters ang nasa 1 liter? Diba? 1,000? So, kung yun ay 1,000 ml, there is 1,000 grams. Kaya po, ang 1 kilogram, ang 1 liter of water is 1 kilogram in mass. Bakit nakuha yon? Kasi definite po ang density ng water. Okay? It has a density of 1 gram grams of water, you have 20 milliliters. Or vice versa. If you have 50 ml, you have 50 grams. O, diba? So, pag alam mo kung anong density ng water or ng isang fluid, makukuha mo rin kung gaano kabigat yung per ml niya or per liter niya. Okay? Now, punta naman tayo, bakit may magkakaibang fluids, klase ng fluids, pero may mga fluids na nag-float siya over another fluid or nagsisink siya. Okay? Under another fluid. Common example natin dito is yung oil and water. Kahit anong gawin natin, ang oil and water, hindi sama kahit i-shake po pa na yan maghapon. Pag binitawan mo siya at nag-settle na sila, makikita mo pa din na magkahiwalay yung ating dalawang klase ng fluid. Okay, anong dahilan doon? Because of their difference in denser fluid. So in that case, yung ating water is denser than oil. Okay? Kung meron tayong 1 gram per milliliter na density ng water, definitely ang ating oil, pwede mo nang masabi na it's less than 1 gram per milliliter. Bakit natin nasabi yun, ma'am? Like, hindi ko alam ang definite na density ng oil. Kasi nga, nag-float siya. Ano bang rule natin? Anong rule natin dun, ma'am Dines? Anong mag-float doon? It's the denser or lower dense fluid? Okay, it's the lower dense fluid.
Okay, fluid. Okay.
Yes, thank you, ma'am. It's the lower dense fluid. Okay? So, as long as the object or fluid has a greater density, it will always sink. Okay? Doon sa RBI example natin kanina, ginamit yung mercury. Kung napansin doon sa RBI natin, no? Sabi niya doon, sa isang klase ng fluid, nag-float siya, sa isang klase ng fluid naman nag-sink. Ang mercury kasi sa heavy metal, no? Kapag naglagay ka ng solid metal sa kanya, limbawa, isang klase ng solid na metal sa mercury, makikita mo na may klase ng metal na mag-float sa kanya. Yung mga klase ng metal na lower ang density than mercury. Kahit metal pa yon, makikita natin na mag-float siya over mercury. Pero pag nilagay mo siya sa water, nagsisink siya. Bakit? Kasi ang mercury at ang water, magkaiba ang kanilang density. Okay? So, laging napafollow yung rule natin na yun, Ma'am Mirna, di ba?
Yes,
ang
ma'am.
laging nagsisink is the denser material. Ang laging nag-float is the less dense material. Yun ang dahilan bakit yung mga ice natin, pag ngayong tag-init, naglalagay tayo ng tubig ng ice sa yelo, laging nag-float ang ice. Kasi nga po, ang ice, it is lesser dense than water. Okay? Yung mga icebergs natin, maka-float ang mga yan.
Yes, ma'am.
Tama po ba?
Opo.
Yes.
Tama yun, ma'am.
Okay. Mga petroleum products natin, like yung mga kerosene, gasoline, ganyan. Pag pinaghalo mo siya sa water, nag-float pa rin ang mga yon. Kasi nga, lesser dense sila. Pero pag ang pinaghalo natin naman ay honey and water, definitely, honey will sink and water will float. Bakit? Kasi nga po, honey is denser than water. So, yun yung rule natin in floating and sinking. It always applies in all kinds of fluids that the denser fluid always sinks and the lesser dense fluid always floats. Ayan. Okay. So, that's all about density, Ma'am Mirna. Ayun, may maganda tayo example dito. We have here, the green one is ethanol. Then the yellow one, lighter yellow, is the refined oil. The blue one is water. The yellow one, brighter yellow, is the dishwashing soap. Red is glycerin. And the brownish color there is honey. So, makikita natin, no? Merong layer talaga, hindi talaga sila naghahalo-halo. Lahat yan fluid. Lahat yan nag-flow. Lahat yan nagpa-follow ng shape ng container. Pero they all differ in density. The densest one is at the bottom and the least in density is at the top. Okay? So, kung tatanungin tayo dyan, anong pinaka-dense dyan? Ano kaya ang magiging sagot ng mga estudyante natin? O pwede nating i-comment. Ano ba ang densest dito? Is it ethanol or honey? So, dalawa lang pagpipilian natin dyan, no? Densest eh. So, the answer is honey kasi siya nakasink sa lahat. And then, ang pinaka-light is the ethanol. Diba? Ang ganda-ganda ng ating example. Okay. So, that's all about density. Balik natin kay Ma'am Jen.
Okay, thank you, Ma'am Benj, sa detailed ang kanyang explanation on density. Ayan. So, we continue with may trivia. Okay, may trivia tayo. Okay, Ma'am Mirna.
Okay, yes, Ma'am Benj. Thank you very much. Ayan napakaliwanag ng explanation ni Ma'am Benj. Kanina nabanggit niya yung ice, 'di ba, nagfo-float because ice is less dense than the water. Pero meron kasi tayong, ito trivia to ha, meron kasi tayong tinatawag na heavy ice. Okay, itong heavy ice na to ay nagsisink sa water. Okay, bakit kaya? Okay, baka later on ma-encounter nyo to, no? Okay, yung tinatawag kasi nating heavy ice is, okay, 10.6% denser than normal water because the ice is made from heavy water. When we say heavy water, okay, it is deuterium oxide, okay, instead of the pure water, in which both hydrogen atoms have been replaced with deuterium, the isotope of hydrogen containing 1 proton and 1 neutron. Okay, so isotope pala siya. Okay, so heavy water is indeed heavier than normal water, which contains a tiny amount of heavy water molecules naturally, and heavy water ice will sink in normal water. Okay, so trivia yan ha. Baka later on may magpakita sa inyo, bakit? Bakit ito? Sabi nyo, nag-float, ba't to nag-sink? Okay, ang trick dyan is, it is called heavy water or heavy ice made up of deuterium oxide. Okay.
Magsisink siya kapag
nailubog sa tubig. Okay,
sa
yes.
normal ice.
Pure water. Yeah.
Okay. Hindi sabihin na ice siya, lagi siyang mag-float. Depende kung anong material sa gawa.
Opo. Okay. Kasi ititrick yan, baka matrick sila, no? And then sabi ni ma'am namin nun ganito. Okay. So, ayun. Shinare ko lang yung trivia natin. Okay. So, thank you, Ma'am Bench, again.
Yan. So, let's continue with another property of fluids, which is surface tension. Okay, didiscuss sa atin ni Ma'am Donabel Velasco. Okay, so for surface tension, this is the property of the surface of a liquid that allows it to resist an external force. So, paano po ito? So, in some given examples of liquids, like for example water, kasi ito yung pinaka-most common fluid natin, there are some materials that tend to float on water. Though these materials are denser than water. Katulad nga nung sinabi ni Ma'am Bench kanina, materials with a greater density than the density of water should sink in water or will sink in water. But because of the surface tension of water, sabi nga, because of the hydrogen molecules that bonds the molecules of water together, napakalakas na bond yan between the different particles of water. It causes a surface tension on the water surface. So makikita natin kapag nag-drop tayo ng tubig, so pag may mga drops of water sa floor or on any surface, sa table, ganyan, makikita natin hindi masyadong kalat yung tubig, hindi po ba? Doon sa gilid niya, para siyang nagka-curve o parang nababanat siya, naghihilaan sila. This is because of the high surface tension of water. Anong nagkukos ng high surface tension ng tubig? This is because of the strong hydrogen bonds that binds all the water molecules together and causes a strong cohesive force, no, among the different water molecules. And this is strong cohesive force among the different water molecules may cause materials to float on water. Okay. So, basahin ko itong nandito sa screen natin. The attractive force exerted upon the surface molecules of a liquid by the molecules beneath that tends to draw the surface molecules into the bulk of the liquid and make the liquid assume shape having the least po ito, surface area. So, nababawasan yung surface area exposed by these fluids with high surface tension. This is because of the pulling together of the different particles of liquids, ano? And this pulling together causes the surface area to be smaller. Ngayon, kaya bakit ngayon nagkakaroon ng pag-float, no, on the surface of water, katulad ng water strider,
makikita natin, ito yung insect na pwede siyang mag-walk on surface of water. Bakit nga ba kaya niyang mag-walk? Kasi hindi pa niya na-break yung hydrogen bonds. Hindi pa niya na-break yung molecular forces or yung cohesive forces that binds together the water molecules. And another one, yung paper clip. Di ba ang paper clip is made up of metal, a very thin metal. Yung mga ductile metal natin. Though maliit siya, pero because of its density, it should sink on water. But kung very careful tayong maglalagay ng paper clip or even a needle or a razor on a surface of water, na kunwari sa isang basin of water, paano natin palulutangin yan? We could make these materials sink or we could make these materials float on water. Na dapat sana sila ay magsisink, pero making it sure na yung surface tension ay hindi matatalo ng force exerted by these materials. Okay? O yung kanilang weight. So, nasubukan ko na yan, Ma'am Mir, na magpalutang ng sa klase. Okay. Nag-demonstrate ako sa klase ko ng grade 7. Kasi this was a lesson during the previous curriculum sa grade 7.
Actually, gagawin sana natin yan, Ma'am. Kaso wala tayong camera. Medyo limited ang natin ngayon sa internet.
So, pwede nating i-float yung needle or paper clip on top of liquids na ipapatong natin yan sa, you can do this at home. Ipapatong natin yan sa tissue and then make the tissue float on water. Nandoon yung needle and then slowly habang nababasa yung tissue, babagsak yan sa ilalim and then leaving the needle on the surface of the water. And makikita natin, habang yung needle na nasa ibabaw, makakakita ka ng parang thin covering na parang plastic sheet on top of the surface of the water, and that is surface tension. Okay? And what are the effects? Ano po ba itong mga effects ng surface tension? Pwede siyang beading of raindrops on a waxy surface, katulad doon sa mga leaves natin. Pag umulan, di po ba makikita natin yung sa mga leaves, especially sa gabi?
Yes, ma'am.
Yung gabi leaves, di ba nakikita natin parang crystal yung shape ng tubig doon because of the high surface tension of water molecules. Okay, and it also causes flotation of some objects. Okay, and para saan itong surface tension? Marami siyang application, pero sometimes itong surface tension, meron din siyang hindi magandang effect. Like for example, sa paglalaban natin o yung pagbuhos natin ng tubig sa buhok. Napansin nyo yan? Pag maliligo tayo, ano yung una nating binabasa?
Actually, yung ulo, ma'am, pero mali daw talaga yun.
Mali yun. Okay. Pero pagbuhos mo sa ulo mo, ano yung unang dapat mabasa sa ulo?
Buhok.
Yung buhok, di ba? Nakakailang buhos ka ng tubig sa buhok before na ma-soak siya talaga with water.
Maraming tabo din,
diba? Ma'am. Maraming tabong tubig. At saka, how will you help your hair get soaked in waters? Di ba, syempre, inaano mo yan? Medyo kinakamot-kamot mo yan. Bakit kaya? Bakit natin ginagawa yon? This is because of the high surface tension of water. And what could... magastos yun sa tubig, di ba? Lalo na binabayaran natin ang tubig natin. And how can we decrease the high surface tension of water? Kasi kailangan i-decrease mo yan para madali siyang makapasok. It could penetrate easily to cracks or pores, or spaces na kailangan niyang pasukin. So, ang ginagawa natin, we decrease the surface tension of water. Ang pagdi-decrease ng surface tension of water is sometimes we add shampoo kapag sa buhok yung binabasa natin. Para nabe-break kasi nung shampoo yung mga surfactants. Yung surfactants kasi nabe-break niya yung hydrogen bonds, na the very strong present among the different molecules of water. Ang ginagawa niyan, brine-break niya yan para pag nagbuhos ka, agad-agad pinapasok ng tubig with shampoo yung ating buhok hanggang doon sa anit. And this is also true with yung wet. Kapag gusto mong i-dump yung mga damit na ilalaba mo, 'Di ba, paano ba tayo pag maglaban ng damit, 'di ba nilalagay natin muna sa palanggana, no? And then lalagyan mo siya ng tubig. Pero napapansin natin, yung tubig, it does not get into the pores of these materials, yung mga damit natin na madumi. Why? Because of the high surface tension of water, unless maglalagay tayo ng detergent. Ano? Kasi yung ating mga detergent, meron yan surfactant that decreases the surface tension. And ito rin ang dahilan kung bakit yung mga tuwalya natin, napansin nyo yung tuwalya? Yung mga tuwalya natin, may mga buhol-buhol siya o talagang sinasadyang may mga rough side siya doon sa isang side, no? O yung may mga unevenness siya doon sa mga magkabilang side ng ating tuwalya. This is for a better absorption of water from our body, galing sa buhok, galing sa saan pa? Sa katawan kapag tayo ay nagpapatuyo ng ating katawan after taking a bath. So those decreases the high surface tension of water. Ano pa yung pwede nating idagdag dyan? Can we see the next slide please? Para maano? Okay. So, how can we explain, no? This two phenomenon we have here on the screen. Yung one tube here is or contains water. Yung isa naman ay may mercury. So these are two different liquids or fluids with two different densities, but both of them have high surface tension. Okay. If we put some water in one tube and some mercury in another one, the water surface takes a convex shape and the mercury surface takes a concave shape. Okay. So, bakit nangyayari po ito? Nagkakaroon po tayo ng development of a meniscus. Ang meniscus may cause the surface to become convex, or it could also cause the surface of any liquid concave. Okay. So, the surface adhesion forces